In this video, we are going to be learning about density. Lab experiments are a major part of any science course. In lecture, we learn concepts that support what we do in the laboratory. In lab, we record measurements such as mass, volume, and temperature, and then perform calculations using those measured values. Scientists record measurements in very specific ways to clearly communicate information about the tools used to collect the data. In this course, you will learn how to read digital and analog instruments, how to record data to reflect instrument precision, and how to count significant figures, and how to track significant figures through calculations. One common early lab experiment involves determining density. Density relates two measured quantities, mass and volume. Mass is a measure of the amount of matter in an object. It is similar to weight, but not quite the same, because mass does not depend on gravity. Common units of mass include grams, milligrams, and kilograms. Volume is a measure of how much space an object occupies, or how large it is. Common units of volume include cubic centimeters, milliliters, and liters. Density is defined as the ratio of mass to volume. Density equals mass divided by volume. In the figure shown, liquids are separated based on density. Less dense liquids, such as lamp oil, float on top of more dense liquids, such as honey. Mass and volume are examples of extensive properties because they depend on the amount of material present. Considering the balls of Play-Doh shown to the right side of the screen, the larger balls have a greater volume than the smaller balls. If we measured their mass using a balance, the larger balls would also have a greater mass. Density, however, is an intensive property, meaning it does not depend on the amount of material. Both the large and the small balls of Play-Doh have the same density. Let's work through an example problem. The density of a metal object is 7.8 grams per milliliter. If a piece of this metal has a mass of 12.12 grams, what is its volume in milliliters? We begin with the density equation. Density equals mass divided by volume. Next, we substitute the given values into the equation. Density is 7.8 grams per milliliter, and mass is 12.12 grams. We are solving for volume, which is in the denominator. To move the volume to the numerator, we take the inverse of both sides of the equation. This flips the equation, giving 1 milliliter divided by 7.8 grams equals volume divided by 12.12 grams. To isolate volume, we multiply both sides by 12.12 grams. This gives 12.12 grams times 1 milliliter divided by 7.8 grams is equal to volume. Isolating this expression gives a volume of 1.5538 milliliters, which rounds to 1.6 milliliters. Now let's do a couple of practice problems. In the first problem, an empty beaker has a mass of 65.713 grams. After adding 23.4 milliliters of a solution, the total mass is 85.741 grams. What is the density of the solution? First, we need to determine the mass of the solution by subtracting the mass of the empty beaker from the mass of the filled beaker. Subtracting 65.713 grams from 85.741 grams gives a solution mass of 20.028 grams. Next, we calculate the density by dividing the mass of the solution by its volume. Dividing 20.028 grams by 23.4 milliliters gives a density of 0.8558 grams per milliliter, which rounds to 0.856 grams per milliliter. For the next practice problem, a medication is supplied as a liquid with a density of 0.85 grams per milliliter. If a nurse needs to administer 250 milliliters of this medication, what is the mass of the dose in grams? We start with the density equation. Density equals mass divided by volume. Since we are solving for mass and mass is already in the numerator, we rearrange the equation by multiplying both sides by volume. This gives volume times density is equal to mass. Substituting in the given values, 250 milliliters times 0.85 grams per milliliter is equal to mass. Calculating this gives a mass of 212.5 grams, which rounds to 210 grams.